will be just the definition of potential energy of the spring. Potential energy gravitational with respect to zero. What will be the formula? Potential energy gravitational with respect to zero. What will be the formula? What is the formula for potential energy gravitational? mg delta y. But if y initial is zero, what will be the formula for potential energy gravitational? mgy with respect to zero. That's the only thing that we can say potential energy at a point, because have to be between 2 points. But if you say potential energy at a point, have to be with respect to the zero configuration. Otherwise, doesn't have meaning. So mgy, or sometimes you will see mgh. Have you seen that before? mgh, that's potential energy gravitational. This is the mgy we are talking about. This is with respect to zero at any point. So at the point of equilibrium, what is the potential energy? Zero. At the maximum point, if it's k over 2x squared, and you graph the potential energy versus x, how will look the graph? A parabola. Right? So imagine that I put this spring here to oscillate with the mass. So if I put that into oscillation with the mass, where do you think that will be the highest potential energy? I am putting along y, it's the same. This is my point of equilibrium. If I extend my new point of equilibrium, right, I extend it now. Look, this is the maximum point, which is the maximum x. Imagine that I am inverted coordinate system instead of x, y. So this will be my x maximum. So when I do this, will be highest potential energy or lower? Highest. When it's passing through the middle point, which is this point, will be zero, right? So now I extend it. Look. So at the lowest point, which is the maximum displacement, from the point of equilibrium, we have the greatest potential energy, which at that point is at rest. Then at this point, we have the lower potential energy. And then at this point, we have again the greatest potential energy, but the potential energy is positive, but will be at the negative value. This is the way that works the potential energy for the spring. Any question on the potential energy of the spring? Good. Knowing that, we learn here, or we have to include here, two equations, very important. Here, work done by the gravity, the potential energy gravitational is mgy. Potential energy of the spring is k over 2x squared with respect to zero. That's the function, what we call the potential energy function of gravitational and potential energy of the spring. Problems. So I just devoted a lot of time for the theory, because this is one of the chapters that has more theory in physics. If you don't understand energy, you don't understand physics. So you can understand the Newton laws, kinematics, this is basic physics. In order to understand physics, you have to understand energy, because everything deals with energy. You hear to Obama, they talk about energy, solar, renewable, not renewable, or whatever, you know. So everybody have to talk about energy, because energy basically governs everything. So, and this is the introduction to how energy works. If we go to electric field, you have to again work with energy. So physics is built, classical physics, also the non-Newtonian physics will be built in the same way. What we have in mechanics, you give energy. The force and kinematics are vectors. It's very difficult to work with. Has direction. To solve problems, then we introduce energy. It's a scalar. They are related. Good news? All right. So, and now we did kinematics and Newton laws. Not for all problems you can use kinematics and Newton laws. You only can use for linear motion or perfect circle. Energy, because depends on the initial and final position. In many cases, we don't care about what path has or what happens in the path. We can use energy and, can solve the problem. Besides that, the solution of problem is more generalized the problem. And if you understand it, make easier the solution. If you don't understand, it's harder. But if you understand it, it's very easy to solve the problem from energy perspective when you understand it. For this reason, I put a lot of emphasis on the theory. I know that it's very boring, and I understand. To hear only, to talk, and not to see a solution of problems, I understand. But it's very important because when you go to the second physics, electricity and magnetism, you will see that everything that you are learning here, you will learn there from another perspective, but you have to understand the idea of energy, otherwise you will be struggling there. You have to understand what is energy from this perspective, general. Work is the integral, delta U is this. Now, in this particular case, I derive two forces, two conservative forces or potential energy, gravitational and this. When you go to electricity, will be the electrical energy, but you will use again this formula and this formula. When you go to quantum physics and the theory of photo effect, you will see that the energy of the photon have to be given to which is the theory of the solar panel. Hit a metal, eject an electron, and that electron is converted into another energy. So at the end, energy is everywhere in physics. Okay, so knowing that, now we go to the last topic of the theory. So basically, the next class will be a solution of problems. The different ways to solve problems from energy perspective. The last topic is the laws of conservation of energy. We learned one already, which is this. The network is the change in kinetic energy. This is the first conservation law. We will learn that this, we will use it in the solution of problems when forces are given explicitly. So you need to recognize, or you need to know, when you have a problem in physics or in mechanics, which of the three theorems we will use to use energy perspective for the solution of problems. And in order to recognize this, we will use it if you see that in the problem forces are given explicitly. The second theorem, which is what we will study now, and the third will be the